Hello! Welcome to the first video pre-lab for Chem 150 this semester. This week's experiment, actually this week and next week's experiment, is the reaction of aluminum with a strong acid. So, why are we doing this experiment? Well, this experiment, and actually the next two experiments, all show us some different ways that we can experimentally determine a balanced chemical equation rather than just learning a bunch of rules like we do when we're sitting around in class. So what is the experiment? What's the chemical equation that we're interested in determining for this experiment? We're going to react aluminum metal with hydrochloric acid solution. Now the whole point of this experiment is, how do we figure out what those numbers are? This is balancing a chemical equation, so we kind of need to know those. Now, what do we have for products? Well, one of the reasons we do this experiment, one of the reasons this experiment works, is because one of the products that we generate is hydrogen gas. So if we're generating hydrogen gas, what's left? This is a single displacement type of a reaction, so the other product must be aluminum chloride, and we'll say that'll stay in solution. And because we want to be very empirical, because we want to be very experimental about this experiment, let's say that we don't know what that number is supposed to be. Now I realize that a lot of you have enough experience that you can probably look at that and, well, maybe you can reach into your pocket and pull out a periodic table and find aluminum on that periodic table and chlorine on that periodic table and make some pretty good guesses as to what the charges are supposed to be. And that'll tell you what this number is supposed to be. But we don't want to do that. We want this to be an empirical determination of this balanced equation. So, what do we need to do? Well, first of all, what do these numbers in a balanced equation really represent? Those numbers are just mole ratios, relative number of aluminum per HCl. So, if this is really just moles, then what we need to do, or what we can do, is determine the number of moles of each of our reactants and use that coupled with our observations to determine what the reaction is going to produce, what the balanced chemical equation is. So what? We're going to take aluminum and aluminum metal. Nice, easy to work with, solid. This actually is regular aluminum foil. We can get the mass of that aluminum in grams, and hopefully by this time everybody is pretty comfortable with converting grams of an element to moles of an element. What about HCl? Some of you may or may not have a whole lot of experience working with solutions at this point. So let's take a little aside here. Your first experiment is going to start with hydrochloric acid labeled 5 molar HCl. Molarity is a concentration unit. So what this really is telling us is that we've got 5 moles of HCl per liter of solution. Well, that's great. What do we do with it? Well, what did we need over here? We needed grams per mole off the periodic table. What about in this case? Well, now we're not going to use grams per mole because we're not determining the mass of the HCl that we're using, we're going to use a known volume. So if I take 5 milliliters of HCl, that's my solution. Molarity is in terms of liters of solution, so what's our conversion factor here? 1,000 milliliters is 1 liter. Now that I know the volume, I can use the molarity. 5 moles of HCl per 1 liter of solution. And I get moles out when I do that calculation. So concentration is just another way to find moles. It's a way to find moles when we're working with solutions. And in a lot of cases, that turns out to be a lot easier than when we're using other ways of determining moles. So that's really going to be the big point of the experiment. We're going to react different amounts of these, and by looking at the mole ratio and our observation, we're going to be able to determine what's going on in the reaction.